How's it going, everyone? Today we're going to talk about how we can use Autodesk Inventor Assemblies to create some VEX parts. Now, specifically, we're going to talk about how we can take a drive shaft and connect it inside of a flat bearing using assemblies in Inventor. So here I've got an assembly. I've already got it pre-made. I have all the parts pulled in that I'm going to use today. I've got a piece of C-channel, a flat bearing that's fully constrained onto my C-channel, and then a drive shaft that has no constraints on it. So let's jump on in. The problem with constraining drive shaft into a flat bearing is that we need to find geometry it has in common, and we encounter a lot of these issues when we utilize Inventor and to create VEX parts, which is how do you put a square peg in a round hole. The best way I have found to do this is to utilize the axis that runs through the middle of one of these holes and the axis that runs through the middle of our flat bearing here. But what is an axis? Well, an axis, if I open up my constraint window here, is an imaginary line. So when we constrain round things together, and we highlight a round face, notice I'm not highlighting the line, I'm highlighting the face here. It grabs this dotted line in the middle, or a center line. And that is the axis, the invisible imaginary line that runs through the center of that circular figure. Now, a lot of things have axes. These cylinders have axes. This has an axis, these little rounded bits. This has an axis here. I mean, everything that's round has an axis attributed to it in an Inventor. The problem, however, is how do I find the axis for a square part? Now, what I have found is that if we go to our model browser on the left side here, and we select our shaft, and to do that, I click the shaft on the model so you can find it on the left side. It highlights blue. I'm going to expand that shaft, and I get a bunch of information here. And this is kind of information overload. You can find the origin of the part, so all the different planes and axes that created it. You can find the sketch that created the part. You can also find different work planes that was used to create the part. But what I like is when we expand work plane 1, we're going to find work axis 1. Notice how that pulls up an imaginary axis that fits in the middle of my flat bearing, or of my drive shaft here. I can tell Inventor, hey, take this axis and that axis and glue them together with a constraint. I'm going to open up my constraint window here, place a constraint. I'm not going to select anything in here. There's nothing to change right now. I'm just going to select this work axis on the left. And the reason why I select it on the left side of my model browser is because I can't click anything here, right? That gives me a face, that gives me a face, gives me a line, gives me a face. There's not a whole lot to select here. So I'm going to select the axis on this left side. And then I'm going to grab the axis from the middle of my flat bearing here, just by hovering over and clicking that curved face. Now you can see my solution here has changed. It's changed for round parts. And I'll hit apply. Now, because those axes are placed together, it's all connected. So let's say you follow these directions and something's going wrong. How do you troubleshoot it? Well, first and foremost, if you see that your drive shaft here is kind of crooked or diagonal in the part, that means you probably did not select both axes. Either you selected just this line here, or just that line, or some variation of that. You may have selected this part. Always go back and check what you did so you can troubleshoot what you did. So make sure you select both axes, and that's really the most important part of this. However, attaching these drive shafts into flat bearings is not that difficult, and you'll do quite a bit of it. So that's where we'll leave it today. As always, if you have any questions, let me know.